High School Musical is what they're doing? Alrighty. So we have drama practice started today. So we're probably going to have the door closed for much of class. So we'll see how that makes the temperature change. I don't know if it's going to get warmer or colder. We'll find out. We'll see how it goes. But every year it's something different. We've been through Aladdin. We've been through Frozen. We've been through something different every single year. Okay. So today we're covering science, which is only on your ACT. It's in the the ACT has its own separate science section. Remember your SAT, they throw their science questions into the reading section, so it's a little different. How many of you guys have actually already taken the ACT? Anybody? Okay, you have. I'm going to put you on the spot. What was the most challenging part about the science section? What do you think? Yeah. So here's the two answers I usually hear. That's one of them. It's like, what do half these words mean? That's usually one of the ones I hear. The other one I hear is that it was so exhausting. My brain was tired. Okay. Those are the two most challenging things I hear about it. Now, as far as the terms, not knowing the terms, that we can kind of fix, right? That we can work on that. Your brain being tired, that's just kind of a hazard of being at the end of the test. And that's one of the really challenging things about the science section is it is the fourth and final section of your ACT, okay? Your brain is exhausted. And it's a challenging section at any stage of the test, and yet they put it last. So that does make it exhausting. However, we're going to work on that. We're going to try to fight brain fatigue with some strategies. Also, the more you it's like training for sports, right? If you're involved in sports or like running a marathon, you don't go out and initially run a marathon. What do? You start by running 1 or 2 miles, and then you work your way up to a marathon. We're going to do the same thing with the ACT and the SAT. We have to train your brain. Okay, we have to train your brain for a long distance run. So we're going to start out by doing 1 or 2 sections of the test. Then we're going to do 3 sections of the test. Then we're going to do 4 sections of the test. That's how we train your brain to get better at doing long tests. Okay? That's the idea. That will help you get through your ACT science section. Okay, so what's in it? Let's talk about that. So we've talked about the fact that brain fatigue definitely sets in at this point. But again, we're going to train your brain for that long distance haul. The second problem that we have is that your time is short. You only have 35 minutes to do 40 questions, and it's 6 to 7 passages. So it's a lot. It's a lot to try and get through in a very short amount of time. We're going to talk about some strategies to try and do time management on this test. It's also over unfamiliar material. Okay, basically anything ending in an ology or an onomy is fair game on this test. Okay, so meteorology, astronomy, nuclear chemistry. I mean, obviously stuff that y'all don't cover in school is going to be on this test. But the good news is that you don't have to worry too much about not covering that in school. Okay, I've had 3 questions in 15 years where I had to have outside knowledge in order to answer the questions on this test. Otherwise, everything I need to know is going to be contained either in the passage or in the charts and graphs, most of the time in the charts and graphs. Okay, and by the way, all 3 of those questions were biology questions. So, FYI. Okay, so that's a lot going against you. Let's see if we can put some things in your favor. Let's put some stuff in your corner. I'm going to move this before I trip on it. Okay. So let's talk structure of the science section. Now, as far as the structure of the science section, it's going to look a lot like the reading section. You got passages and you got questions after them to answer. Your science sections are actually broken into 3 different categories. This is type 1 and type 2. Your type 1 are your charts and graphs, okay? So charts and graphs, your ACT just calls this data representation. It's like whatever, we're going to call it charts and graphs, it's easier. These passages always have exactly 5 questions after them. They always come with lots of figures and graphs. There's going to be 3 of these for a total of 15 questions. these are going to be your fastest to work. You want to do these first, okay? There's usually nothing to read, or if there is something to read, it's like 2 sentences. So it's not time consuming. So this is definitely where we want to start. We want to do all those guys first. The second type we're going to deal with are our experiments. So our experiments, or ACT calls them research summaries, these have 6 questions per passage, and they normally come with figures or graphs or tables of some sort. But they're going to have more text that you have to read through because they have to explain the experiments to you. So we do these second because we do have more to read, but we still don't have a lot to read. So we do these guys second. Okay. There's going to be 3 of these. Again, 6 questions apiece. So that's a total of 18 questions. We work these guys second. On your next page, you have type 3. And thank God there's only one of these. These guys will take you the longest, and they're highly annoying. I call these guys the spatting scientists. ACT calls it conflicting viewpoints. It could be scientists arguing, it could be students arguing, whatever it is. These guys are a pain in the rear. There's only one. We're 7 questions. This is kind of like your dual passages in your reading section, okay? But instead of having like 2 opinions or 2 passages, you might have up to 5 different conflicting opinions, okay? And the 5 different explanations, up to 5, it may be less, will be trying to explain something that's going on, okay? So they're going to give you some sort of phenomenon, and they're going to say, this guy thinks that this is the explanation, this guy thinks this is the explanation, this guy thinks this is, and you have to make sense about all that. These guys are annoying. The way we tackle these is we tackle them the same way we do the dual reading passages. You only read one opinion. So you read guy 1's opinion first, answer any questions you can, and rule out any answers you can about the first opinion. And then you go back and read opinion 2, repeat, go through all the questions. Then read opinion 3, repeat. But that's why it takes so long, okay? This guy always goes last. All right. So we've got some general tips for finding easier passages. A lot of times these help, a lot of times they don't. Quite honestly, if you're doing the passages in order from your data, if you're doing your charts and data first, and then your experiments, and then your arguing scientists, if you're doing them in that order, you could go back and reorder your passages within each category based on this information. But to me, this takes more time. I would much rather just go, oh, I got a charts and data question, I'm going to do that. I got an experiment passages, I'm going to do those second. I don't worry a whole lot about this, but again, if you want to try to employ this, you're more than welcome. Okay. You may also want to, like if you're really struggling with the science section, something else you can do is look for topics that interest you. So if you're really into biology, do your biology passages first. If you're really into chemistry or physics, do those second, okay? Whatever you're really into, you might want to kind of focus on that area. There's been some evidence that that also helps to improve your score. All right, let's talk about scoring. So your science section is actually curved. It is the only section on your ACT that's curved. It is a straight up bell curve, which means it can only help you, it can never hurt you. And it is published on ACT's website, so you can see what it is. It's not usually much of a curve. It's usually like maybe 1 or 2 points, okay? So don't rely on it. It's not going to be much, but it is out there to help you, okay? All right. Plan of attack. Oh, I kind of skipped over timing. I apologize. Let's talk about timing. Timing is a premium on your science section, okay? So don't sabotage yourself. If you get to a really hard question and you have absolutely no clue what they're talking about, pick your letter of the day and move on. Don't dwell on it. You may come to an entire passage, okay, that you have no idea what's going on in the whole passage. That's fine. Letter of the day, the whole passage. Move on. Don't sabotage yourself when it comes to timing. Every once in a while, you will hit a horrible, horrific passage. There was one that was in a practice test that was something about bird beak depth and how the depth of the bird beak is going to change based on evolution and where the bird lived. It was the most horrific passage ever. Sir?
So all the tricks you told us about SAT questions about how like lower level words necessarily are usually not the answer choices. That's one thing you said, right? And then any answer choices that start with prove or anything like that. So should
No, not on your ACT.
No? Okay.
No, those are SAT things. So SAT does not like extreme language. And that does also go for your ACT reading passage. Okay, those tricks for your reading passage work great. When it comes to the science, absolutely not. Those are only reading strategies. Okay. Yeah, your science is kind of a different booger altogether. Good question, though. Very good question. Okay, let's talk plan of attack. You also won't really run into that here. You're not going to really run into those opinions with that strong language. You know, won't run into the same question types, which is good. All right, first of all, order your passages. So we're going to order our passages, again, based on those question types. We're going to do our charts and graphs first, and then we'll do our experiments, and then we'll do the arguing people last. The second step is going to be to work the figures. This should take you 10 to 30 seconds. Basically, you're going to look at a graph, and you're going to mark a trend. Okay, so what do we mean by trend? Let's look at an example. Okay, so if I have a graph, and let's say that on my graph, it's doing this. Okay, generally speaking, whatever my variable is here, it's going up as it goes from left to right. Okay, generally speaking, things on the x-axis usually increase from left to right. I would have to check the numbers, but as this goes left to right, this is increasing, and then as this goes up, this is going up as well. So basically what I'm saying here is, generally speaking, my trend is, as this is increasing, that's increasing. Okay, does that make sense if my graph is generally speaking going up? It's got some dips, but it generally is going up. Make it a sense? Okay, we can go the other way too. If I have a graph that's doing this, and again, he may have some peaks and valleys, but he's still generally going down. So my trend for that guy would be down, down. Up, down. This is still going up, but this guy is going down. So as I go left to right, this is increasing, but he's actually decreasing as he's going down. That's a general trend. Make it a sense? Okay. This is something I would want to see on an ACT passage. This is something I would look for, because trends make for easy questions. So this is something I'd want to hunt for and definitely want to mark. Now, what I don't want to see in a passage, what's a bad thing to run into, is a graph that's doing this. I can't make heads or tails of that. I can't say as my x variable increases, my y is increasing, or as my x is increasing, my y is decreasing. I don't have a general trend here. It's like going all over the place. Okay, so this is a bad situation. This is a good situation. Okay, make sense? All right. So when we talk about trends, this is what we're talking about. And we're going to do examples where we're going to have this stuff. B, are the variables increasing or decreasing? Again, that's our arrows. And then what's the connection? So if you have a passage where you have multiple graphs or charts, you want to figure out how those graphs and charts are connected. What variable is the same between them? Okay, so if your graphs and charts look different, what's connecting them? What's the same? How do they go together? Try to make that connection right off the bat. If your graphs and charts look the same, then look for what's different. So if they look like they're different, or if they look like they're the same, look for what's different. Okay, and usually the difference between them is going to be found in the key. Always look at the key for your graph. Always, always, always. Okay, it's going to give you important information. Okay, any questions on working the figures? And again, we're going to do examples. Okay. All right. Next up is number 3, working your questions. There's absolutely no order of difficulty here. So if you hit a hard question, again, fill in that letter of the day and just move on. You want to answer your questions pertaining to any trends or anything on your charts and graphs first. Anything where you have to actually read or look for in the passage, just mark with like a P for passage and move on. And once you have all the ones that are in the passage marked, go and look for all of them at the same time. Saves you time. Ooh, technology fail. There we go. Okay. All right, last step is just to work the passage. So if we have to, we'll actually go back and read the passage. We try not to, but sometimes we do. So we'll go back and just kind of glance through the passage and try to find anything that we're missing. Okay. And then we already talked about the spatting scientists and how we're going to work them, so we don't have to go through that. So your bottom line when it comes to your science section is that to get a good science score, it takes 0% outside knowledge and 100% practice. Okay, the more you do these, the easier they're going to get. They're going to be real foreign at first and really difficult to do at first, but the more you do them, the easier they're going to get. All right, let's talk about the question types. Okay, let's get into the elephant in the room. This is one of the hardest ones for people to deal with, but we're going to try to make it easy. So, the scientific or exotic terms, you're likely going to encounter quite a few of these because, again, you're going to be dealing with topics that you don't usually deal with in school. Anything with an ology or an onomy on the end of it is fair game. Okay? So, when you encounter a word you don't know, it's probably going to fit into one of these three categories. It's either going to be a term that's going to be explained in the text, so you don't have to know the meaning because they're going to tell you the meaning. Or two, it's not going to be explained because you don't need to know it to answer the questions. So there's no point in them explaining it. Or three, it won't be explained, but all you're going to have to do is match up that same weird word that's in your question to the weird word that's either in the passage or on the diagram. Okay, so all you have to do is match it up. We don't have to know what it means because we're just matching. Okay, so let's look at an example of that. ACT number 3. According to figure 1, which of the following correctly orders the enzymes according to their enzyme velocities from highest to lowest after 1 second at a substrate concentration of 12 millimolar, I don't know what that is, and a temperature of 40 degrees Celsius. Okay. All right, so I'm just going to play the matching game here. So enzyme velocities, they're talking about enzyme velocities. If I go to my graph, oh look, right there, enzyme velocity. Okay, cool. And they want it from highest to lowest at 1 second. 1 second, there's 1 second. So I'm looking at these guys. They want it from highest to lowest, so we're going top to bottom. On the top I have an X. If I match that to my graph, or my key, my X's are enzyme D. My next one down is this light colored one, which looks like the little squares, which is enzyme B. And I could figure out the other two, but if I look at my answers, I don't have to go any farther. There's only one that starts with DB, and that's answer choice D. Okay, any questions on that? Sir?
I understand the graph part. This is going to be a dumb question, but what does the 40 degrees Celsius have to do with it?
It's probably the conditions that are matching up to the graph. So there's probably something in the passage that talks about it being at 40 degrees and 12 millimolar or whatever the MM stands for. But you don't even have to know that. Just match it to the graph because it says see figure 1. So we don't even care about that.
So say there was a question and we had to know about the 40 degrees, should we go back to the, obviously go back to the,
Then go back in the passage, yeah. But those two numbers don't make any sense on figure 1. Right? So if they say see figure 1, I don't have to worry about that. I just go to figure 1.
Why does it talk about like the concentration of like 12 millimoles? Like what we're
This is time, and that's velocity. There's no concentration anywhere on this. Right, so that information, that 12 and the 12 and the temperature, completely irrelevant to this chart. It's probably the conditions under which whatever this experiment was were performed. But we don't care because it just says see figure 1, so we just go to figure 1. You're going to find a lot of times there's going to be information in these questions you just ignore. You don't care. If it says see figure 1, you go to figure 1. Okay. Any other questions? Yeah, okay. All good questions though, guys. Very good questions. All right, ACT 14. This is a match up the weird word question. So and a definition question. It has both. So the range of a zone refers to the distance and depth between the top and bottom of that zone. Okay, so right there, they're giving you the definition. So they're telling you the range is the distance in depth between the top and bottom. Okay, so boom, we've got a definition. According to figure 1, which I've recopied, which two zones have similar ranges? And then they give us weird words. Okay, so let me scroll up and get this graph on here. Okay, so this is figure 1. And I can get most of the graph in here. You can see enough of it. So again, they said the range is the difference in depth. So this graph is a little backwards of what we're used to seeing. We're used to seeing like depth or height on your y-axis. But if we look at it actually on our x this time. So depth is on our x. They told us that the range is the difference in depth from high to low. So our range for anything, for any region, is going to be the width of this column. It's going to be the high minus the low. Okay, so that would be the range for this one, which is called the abyss. I'm not going to try to say the weird word. And this would be the range for this guy. And that would be the range for this guy. Okay? And then there's a little one over here, which I can't fit range in. But does that make sense? Again, if it's the difference in depth and your depth is on your x, then the range is going that way. Okay? Make your brain work different. All right, so that's the difference in range. They want to know which two zones have about the same range. So all you're really doing is looking for which two columns are about the same. So which ones are about the same width? Well, this guy and that guy. So follow those up. What are they? They're this one and this one. So the abyss one and the bath one. So if we scroll back up, we want the abyss one and the bath one. And again, all I'm going to do is match their names. So the abyss, which is this guy and that guy, and the bath, which is that guy. So it's got to be J. Okay. So again, weird words I don't know, but I just have to match them, so I don't really care what they mean. Okay. All right. Next type of question. The next type of question we're going to deal with is information is stated directly on the page. And this is where most of your science questions are going to fall. Thank goodness. So we've got a few different subtypes within this. The first subtype is info in the passage. So if we have info in the passage, then we actually have to go hunting for it, unfortunately. So here's question number 5. In experiment 1, which of the following variables was the same for all 4 zinc alloy coin samples? So when I go to my experiment, I'm going to look for something that says, like all samples were, like that would be a good indication that we're talking about everything. So let's see what we've got. Chemists obtained 4 coin-like samples of a high percentage zinc alloy. All samples were, okay. So all samples were circular, had a radius of 1, and had the same thickness. I'm looking for one of those 3 things. So go to my answer choices. Which of the following variables was the same for all 4 zinc alloys in coin sample? The change in mass from plating. That was not circular, radius of 1, or the same thickness. That was not one of those 3 things. Electric current applied? Nope. Type of precious metal solution used? Nope. Initial radius of sample? Had a radius of 1? Yes. Okay. Make sense? It's literally word for word. Your ACT is not going to try to trick you. It literally is word for word right out of the passage. Okay? They're not going to mess with your brain. All right, so that was type 1, info out of the passage. This is type 2. This is info from the graph. A lot of your questions are going to be in this category. So in experiment 2, at each sunlight exposure, which AS mixture resulted in the fewest surviving T verdicts? All right, fewest surviving. Oh, look, percent survival on my y-axis. If I want the fewest surviving, then I want to know which one was the lowest. Who died? All right. So the lowest one looks like that guy, looks like that guy, looks like that guy. Okay, so go to your key. Which one is the little stripy guy? And the little stripy guy up in your key, horizontal stripes anyway, looks like it was glycerol. So go to your answer, glycerol. Okay. Again, straightforward, they're not going to screw with your brain. All right, next question type up is trends. We have a few different trend subcategories. Type 1 is your general trend questions about your graphs and charts. So ACT number 1, based on the figure to the left, as temperature increases, the solubility of HgCl3 does what? So every time we have a trend question, we want to go ahead and mark our trends on our graph. So before I even try to figure this out, I'm just going to look at my graph. What's temperature doing as you go from left to right? Is it going up or down as it goes from left to right? Going up, right? So temperature's increasing. And then overall, what's my graph doing? All of my lines, generally speaking, are going up in some way, shape, or form. Okay, this guy's got a little flat spot here, but I'm not going to worry too much about that. For the most part, they're all going up. So as temperature increases, solubility increases. I don't care what chemical it is. As temperature goes up, solubility goes up. So back to my question, based on the figure to the left, as temperature increases, the solubility of this thing increases based on my trend. I really don't care what chemical it is. Okay. Making a sense? Okay. All right, so that's a trend question. This is another one. Again, before I read the question, I'm going to look at my graph. Conductivity on the x-axis. As it goes left to right, it goes up. So conductivity is increasing. But my graph overall is going down. So as conductivity increases, battery current's decreasing. That's my general trend. So back to my question. Based on figure 1 and figure 2, I only gave you figure 1 because you only need figure 1. As conductivity increases from 200 to 500 at room temperature, what does battery current do? Well, as conductivity increases, battery current decreases. Decreases only. Okay? Don't make it this hard. All right, let's talk prediction questions. People hate these. I don't know why, but people hate these. Generally speaking, they're not going to ask you to predict a specific number. They're going to ask you whether something is going to be less than something, greater than something, or in between two numbers. And most of the time, you can just apply a little common sense and figure this out. Okay. You may have to do a little basic math, but I mean, it's going to be really basic because you do not have a calculator in this section. Okay. So let's look at an example. ACT number 2, based on figure 1, over there. If a culture of fibroblast cells was surrounded by a toxin concentration of 90 parts per million, the percent of those cells that would undergo apoptosis, or whatever that is most likely which one of these? Okay. So concentration of 90. Well, here's my concentration. 90 is not on my graph. It is over here. So I need to see if I can predict what's going to happen. Now there is a data point right here. It's really faint on your paper. So I'm going to go ahead and color him in. So I need to look and just see if I can predict what's going to happen. Generally speaking, what's my trend? As toxin concentration increases left to right, my AI, whatever that stands for, is also increasing. So that means whatever 90 is going to be, whatever 90 is going to be, it should be above this number. Okay, does that make sense? Okay. So it's going to be higher than, it should be higher than whatever this number is. So this number is 0.007, which is 0.7%. But even if you don't do that calculation, I would hope that you'd be able to match up the fact that you've got 0.07 and then you got 0.7%. They're going to go together. So it should be higher than 0.7. Okay. All right. Questions on that? Okay. We're going to have that a lot. So you guys have to tell me if it gets too distracting having a lot of singing and drama noise and everything going on. We can change times, but we would have to come after 1 p.m. So it's up to you guys if you want to give up the middle of your Saturday or if you want to stay in the morning. My goal was to get you guys in and out so you still had your Saturdays. So I'll leave that out there. Y'all can think about it. We'll see how distracting it is the rest of the day. But we are going to have a lot of noise coming from drama. Okay. ACT number 18. So this is another prediction question. This one has to do with chemical formulas. All right, so CH3, CH2, 4COOH is the chemical formula for the carboxylic acid named hexanoic acid. Based on table 1 over there, this compound most likely boils at what temperature? Okay, well, first of all, I'm talking about boiling, right? So cross out the stuff you don't need. I really don't care about the name, and I don't care about the freezing point, so just get rid of it. It's annoying. It's in your way. Then we got to figure out where this thing goes in this table. Does it go between something? Does it go at the top? Does it go at the bottom? So we got to look for the pattern. Well, other than the first one, they all start with CH3. This starts with CH3. Okay, so that's not real helpful. CH2, 4. Well, what's going on with the CH2 thing? Again, the first two, not real helpful, but then I see CH2, CH2, 2, CH2, 3. Aha, I have CH2, 4. So I've got 2, 3, 4 would be the next one in the series. So this thing should go at the bottom. This thing should go underneath this. Does that make sense? Does anybody have any question on where I put this? Okay. So this guy is going to go underneath here. He's going to be the next one in our series. It's important to be able to figure out where it goes in the pattern. Okay, now they want to know the boiling point. Well, if I look at my boiling point, it's increasing, it's going up. So it's got to be higher than 186 for sure. Does that help me? Well, it can't be lower than 180. Let's get rid of that. So it's at least got to be one of the bottom 3. And if I look at the jumps, like how far it's going up, higher than 250 seems like a bit of a stretch. So we can probably remove him. So we're at least down to a 50-50 shot. Now let's see if we can figure out which one it is. Well, let's do some basic math. Let's figure out how high it's going up each time. Okay. So again, basic math, you don't have a calculator, got to do a little subtraction. So from 108 to 118, that went up 17. From 118 to 141, you'd have to do 141 minus 118, which is 23. Ooh, made the brain work this morning. From 141 to 164, that's 23 again. From 164 to 186, that's 22. Okay, so it went up 17, then it went up 23, then it went up 23, then it went 22. I'm going to kind of disregard that first 17. The other 3 match quite well. Sir?
Before you do all that work, can you cancel that G because you're not supposed to equal 180?
Well, it says between 180 and 215. So, yeah. What if it's like 201 or 202? What if it's on the upper end of that?
Does it include 180 or is it saying 181?
It could be anywhere in that range. If it came, that's the problem, is it could be anywhere in that range. So what if it came out to be 206? Then it's still somewhere in between there. It's not saying that it has to be at the low end. It's saying it could be any number in between there. I'm sorry. Can't take it. It's got to stay there. But I'm going to say that this is going to go up by either 22 or 23. So take your 186. Let's choose on the low end 22, but you can use 22 or 23. Add, you're going to get 8. 0, carry 1. You're going to get 208. So you need something around 208, 209, which is going to be G. But that's how you figure it out. Yeah. So it could be any number in that range. It doesn't have to be the low end. Your brain is working like the SAT. You think they're trying to trick you. They're not trying to trick you. Yeah. It is because you guys have been indoctrinated into College Board by the school system down here. My kids that live up north because I have kids all over the country, and my kids that live up north that take the PACT in school and take the ACT in school, which is basically anybody between Denver and Pittsburgh, their brains all work like the ACT. So their brains are like, this is no problem. But when I start talking to them about the SAT and tell them they're going to trick you, their brains can't think like that. So it's a matter of kind of changing your thinking, and it's hard. It's hard. I don't lie to you. Okay. This guy, chemical equations. These, I don't want you to stress out over this if you have a hard time with chemical equations, okay? You're looking at a maximum of 1 to 2 questions per test, maybe. Sometimes there aren't even any of these on there. So you may go, if you take the ACT 3 or 4 times, you may not even see a chemical equation, a question. So if you have a hard time with chemical equations, please don't stress about this, okay? But let's look at how to solve them. Your best bet with solving chemical equations questions is just to use ratios, okay? Let's not make this difficult. So, this part right here was actually in the passage, but again, I cut it out and put it in the question so you had it. In water, hydroxide reacts with nickel to form nickel hydroxide, monohydrate, which is that thing. The balanced chemical equation for the reaction is blah. Based on the balanced chemical equation in the passage, as 6 OH negative, okay, so we're going to have 6 of these guys, are consumed, how many formula units of this mess, the other side, are produced? Okay. Yeah. Believe me, Aladdin was worse. Okay. So, we can only hear A Whole New World so many times. So, let's look at this as a ratio question. If we look at our original question, for every 2 units of OH negative, we get 1 unit of the thing on the right, which I'm not going to rewrite. Okay? Now they're telling me I've got 6 of the thing on the left. And they want to know how many things on the right am I going to get. And then all you have to do is cross multiply, you can solve. Okay, so 2 times x is 2x. Just drop all your letters. 1 times 6 is 6. X is 3. You're going to wind up with 3 of those things on the right. Okay. Any questions on this? Any questions on chemical equations? Sir?
How do you get 6 for the 2
They told us in the problem that we had 6 OH negative ions. Oh, yep. Minor detail. Yeah. Yeah, it's all good. All right, any other questions? Ma'am? The 2OH is from your chemical equation right here. Yep. Okay. Cool. All right. Next up, we have basic experimental design. Need a drink. All right, so these questions are going to ask you about the experiments being performed. And they might ask you to design your own experiment, which sounds absolutely horrific, but it's really not that bad. They might also ask you what the scientists are trying to discover, or what they're trying to figure out by doing a certain experiment. So this is easiest shown just with an example. So number 24, in experiment 1, which of the following questions were the researchers most likely attempting to answer? I could read the passage to figure this out, but before I read the passage, I'm going to look at the graph and see if I can figure it out from the graph. Here's my graph. So what's on my graph? On my graph percent by volume of NaCl or weed killer. Okay, so the two things involved in this experiment were NaCl, which by the way is table salt. So salt or weed killer. That's what we're dealing with here. Okay, these are the two things that are involved in my experiment. And I'm seeing apparently percent survival, I'm killing something. So what can I kill with salt or weed killer? Probably killing weeds. Okay, but that's basically what we're doing here. Salt and weed killer. Now let's look at our, quit ringing. Let's look at our experiments. Let's look at our answers. So again, salt and weed killer. If I look at F, does the percent survival for T. vernix sprayed with cornstarch differ from the percent survival of T. vernix sprayed with glycerol? Here I have cornstarch and glycerol. That is not salt or weed killer. There is no cornstarch or glycerol in my graph. G, does the percent survival of this thing sprayed with weed killer differ from the percent survival sprayed with NaCl? Aha! Weed killer, NaCl. That's what's in my graph. That's probably my answer, but let's keep reading. H. Is the percent survival of TX sprayed with NaCl and percent survival played with vinegar? Okay, so now I have NaCl and vinegar. There's no vinegar in my graph. Remember that. J. Is the percent survival of T. vernix sprayed with NaCl and the percent survival sprayed with weed killer, aha, we have the two right chemicals, affected by increasing the sunlight exposure from 3 to 6 hours? Is there any sunlight exposure in my graph? No, that's not in my graph. If it's not in my graph, then it's not going to be in the results of my experiment. So that's out. It's got to be G. So no reading necessary. We can figure that one out. If I could not narrow it down, then I would go back and read the experiment and figure it out from the paragraph. But okay. ACT number 4. I don't remember what this one's about. Oh, the hamsters. That's right, the stupid hamsters. Okay. This whole passage was a pain in the butt. Okay, number 4. Which of the following experiments could be used to determine if the fruit juice preferences of recently captured European hamsters from Russia are the same for a different species of food source? I'm like, who cares? Okay. So I have European hamsters from Russia. Lovely. All right, let's go see what's going on in these experiments. All right, so what happened here? So I'm just going to start with up here at the top. Hamsters forage and hoard many types of seeds and nuts. True statement. Scientists hypothesized that the European hamster, I'm going to skip the Latin, would be more drawn to hoard seeds soaked in certain fruit juices over seeds soaked in other fruit juices. Aha, there's what they're testing, which fruit juice they liked. 3 experiments were performed to test this hypothesis. Experiment 1, seeds from pumpkins, whatever that is, were soaked in juice from 1 of 5 different fruits. Okay, so seeds from pumpkins, that's their food source. This is what they're soaking, so they're using pumpkin seeds as their food source. And I know my question asked something about food source, so that's going to be important. Blah, 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 blah. I want to know about these Russian hamsters, so I need to figure out where these hamsters are from. So I'm just going to kind of skim. Here, hamster that was recently captured in Belgium. That's not helpful. I want Russian hamsters, not Belgian hamsters. So experiment 1, not helpful. Go to experiment 2. The procedure for experiment 1 was repeated with the same set of 25 hamsters from Belgium, not helpful. Experiment 3, the procedure from experiment 1 was repeated except with 25 recently captured hamsters from Russia. Aha! So experiment 3 is my one with hamsters from Russia. So if I go back down to my answers, I know I need experiment 3 because that's where my Russian hamsters are. So those are out. Got to be experiment 3. Now, again, what are they trying to test? They're trying to test if the fruit juice preferences from Russia are the same for a different species of food source. Okay, so what was their food source? Their food source were those pumpkin seeds, right? Okay. Now, they've got C. pepa in here. If you go back and look at the Latin name of those pumpkin seeds up in experiment 1, it's got a really long first word that starts with C, but then the second word is pepa, P-E-P-A. So there's your C. pepa. Pumpkin seeds are the C. pepa. So C. pepa, it means pumpkin seeds. Okay. So again, that's just matching. Make sense? Okay, so we have to decide if they want to keep the pumpkin seeds as a food source or change to a different one. Again, what are they trying to test? They're trying to test if the fruit juice would be the same, their preference would be the same, for a different species of food. So for a different food source. So if I want to see if it's the same for a different food source, I need to change the food. So that would be J. Okay. Any questions on that? Does that make sense? All right. Okay. All the questions for that passage were like that. They were all awful. Okay. All right, our last, I think this is our last section in the packet, is going to be about just applying some common sense. Yeah. I didn't think these questions were too bad, but again, I have common sense. So if you got it, you got it. If you don't, you don't. ACT number 2, according to figure 1, KNO3 and KCl have the same solubility at what temperature? Okay, so I'm just going to match things up. KNO3, here's KNO3, so that's this graph right here. KCl, that's this graph right here. And I want to know where they have the same solubility. So the same solubility is going to be where they intersect. That's right there. And if I drop that down and look at the temperature, because again, they asked me for what temperature, temperature's on my X. If I drop that down, it's going to be just to the right of 20. It's not quite 20, it's close to 20, but it's just to the right. It's not quite at the line of 20, okay? So it's just to the right of 20, so that means it's somewhere between 20 and 30. So somewhere between 20 and 30. Okay. They're never going to give you something like this and go, oh, it's 21.5. You won't have to do that. Okay. All right, okay with that? All right. All right, let's use some logic on this one. Okay, so the chemists were to repeat experiment 1. We don't know what experiment 1 is. I didn't give you the passage. You don't need it. But compress each coin sample to a radius of 0.5 centimeters to decrease the surface area exposed to the surrounding solution. How would the mass of precious metal plated most likely be affected? Okay, so let me explain how precious metal plating works, because this was explained in the passage, which I didn't give you. So the way metal plating works, like if you have like a gold-plated ring or a gold-plated necklace, the way they did that, well, one of the methods they could use, is they take that shape, whatever it is, with its base metal. So a base metal may be nickel, that's a real common one. And they're going to take that shape, in this case it's a coin, so a coin made out of a base metal like nickel. They put it in a solution with the precious metal dissolved in that solution. So you'll have gold ions floating in this solution. They then run a current through that solution, that liquid, and then all of the ions will just adhere to the outside of that coin. Okay? That's how precious metal plating works. That's how you get something that's gold plated or silver plated. All right, now, and again, that was all explained in the passage. So what they want to know here is that they're going to, if they compress that coin sample to a radius of 0.5 centimeters, so they're going to compress means to make smaller. So they're going to take this larger coin and make it smaller. If they make that coin smaller, that means your surface area is smaller. You don't have as much space on the outside. If you don't have as much space on the outside, what's going to happen to the amount of gold or silver that could stick to that? It's going to go down. You don't have as much room for stuff to stick to. Right? Make sense? Okay, so how would the mass of precious metal most likely be affected? It's going to decrease. I don't have as much stuff to stick to it. So the mass is going to decrease for all the coin samples. It's not going to go up for some and down for the other. If you shrink them all, it's all going to go down. Okay. All right. That's that guy. I don't want to be up there. Why is it up there in the menus? Try again. Number 4. Conductivity measures a material's ability to conduct an electric current as defined as the reciprocal of a material's ability to oppose the flow of electric current, which is the resistivity. If a scientist wants to increase the conductivity of a material they invented, what would they do? Okay, so let's dissect this. Conductivity. They want to increase the conductivity. Okay, we're hoping for conductivity to go up. Well, conductivity is defined as the reciprocal of the resistivity. So reciprocal, that's like an inverse. Like as one thing goes up, the other one goes down. As one goes down, the other one goes up. Okay, that's what reciprocal means. So if conductivity is going up, then resistivity should go down. Make sense? Yeah? So if I want conductivity to go up, I got to get resistivity to go down. If I look at my answers, oh look, decrease the resistivity. Okay, I know nothing about length or cross section. There's no information in here about that. Those can go out the window right away. All right, we good? All right. Okay, guys, so that's the end of the science packet. Now I have practice test for you. Now we're going to play. All right, so let's do this. Let's take a break, and then we're going to do science. So feel free to open the door and move around. I'm going to pass these out while we're on break. Yeah, no problem. Down there. There we go. It's better than listening to repeatedly listen to A Whole New World or Let It Go. So. All right. Okay, guys, I'm going to try to do this one on, this is a program called Ziteboard. I'm going to try to do this on Ziteboard so that like arrows and notes and stuff stay. Otherwise, I have to keep erasing them and you won't be able to see when we scroll down. So it requires me to sit down, so I apologize, but this is going to be the way it is. All right. So, I handed you guys the science test. I'm like, I didn't give you the test. Yes, I did. Okay. Where's mine? It's over here. Okay, so we're just going to try and get through the first two passages, and that's going to be it. So this is the first passage. Now you can tell because this says study 1 and study 2 on it, that immediately tells us that this is an experiment passage. Okay, so right away we know this is actually an experiment passage. So we wouldn't really normally be doing this first. We'd be doing charts and graphs first. But the charts and graphs passages are usually the easiest for students. So I'm like, if we're going to go over something, we're going to do the hard ones. So we're going to do the experiment ones, and then we're going to do an arguing people one. So experiment 1, that's this guy. So the first thing I'm going to do, I'm not going to read anything they tell me. I'm just going to look at my graphs. So let's look at our graphs and let's mark our trends. So on our graphs, we have figure 1 on the left, okay? And I want to mark my trend. So on the bottom, you have your days, and that's increasing from left to right. So on the bottom, I'm just going to put an up arrow to show that my time is increasing from left to right. And then my percent alive is obviously decreasing. Whatever these things are, they're dying off. So I'm going to put a down arrow. Figure 2, we have the same kind of thing. My time is increasing from left to right, and my percent alive is decreasing. Now, these graphs look a lot alike. So if your graphs look alike, you want to look for what's different. Okay, remember, if your graphs look alike, we look for what's different. If your graphs look different, we look for what's similar. We always look for the opposite thing. Okay, so typically what's different is going to be in the key. So if we look in the key, what's different between these two graphs? What do we see? The percentage of whatever this stuff is that we don't know, that we don't care. Okay, but the percent is different. So I'm just going to make a quick note at the bottom that this guy is 15%, and this guy over here is 5%. Okay? And that just makes it a little easier for me to see later when I have to refer back to it. Okay, on to the next page. I have another table. I have table 1. Let's take a look at that and see what's going on there. So table 1, we have strain N and strain X. I don't know what those things are. Don't really care right now. My percent sugar, as I go down in my table, it's actually increasing. So I want an up arrow there just to show that that trend is increasing. Same thing with the percent killed yeast. Oh, look, over the top it says SY medium. So what do you think S and Y stand for? Sugar and yeast. Aha, we've solved a mystery. Okay, percent killed yeast is also increasing as we go down. And then our average lifespan is decreasing. So we're going to put a down arrow there. And then the same trend is true with strain X. So this is increasing, this is increasing, this is decreasing. Okay, so again, if my trends are the same, I want to look for what's different. So what's different between strain N and strain X? Who's living longer? Yes, ma'am? X is living longer. Okay, so I'm just going to make a note here. These guys are living longer. Live longer. Okay. Now, I should probably figure out what the difference is between strain N and strain X because that's probably going to be important. So to do that, I'm going to have to read. So let's go up to study 3 and just read. Strain N fruit flies were modified to produce strain X fruit flies. Strain X fruit flies lack OR3883B, a protein required to detect a wide range of odors. Therefore, they cannot detect many odors. Aha! Their sniffers are broken. Okay. These guys cannot smell stuff. So can't smell or can't detect odors, however you want to, sniffers are broken, however you want to notate that. Okay. Just some way to notate how they're different. All right, on to the questions. Question number 1. In which of studies 1 and 2 did some of the fruit flies live for more than 75 days, and what diet were they fed? Okay, studies 1 and 2, we know we're on the first page. So we're looking for who lived more than 75 days. So back to our charts up here. So study 1 or study 2? Who had somebody that actually made it to 75 days? Yeah, study 2. Yeah, so study 2 had this one little data point. Somebody right here actually survived 75 days. So study 2 made it, and we know because we made this note that study 2 was the 5% people. So study 2 and 5%. Okay, so study 2, 5%, back down here to question 1. Study 2 and 5%, that would be C. Okay, number 2. During studies 1 and 2, why did the size of the fruit fly population in each tube decrease rather than increase? That is not on our charts or graphs, so that has to be a passage question. So we're just going to mark him with a P and move on. We'll come back to him. What we can do, though, is just kind of glance at our answers. We have the birth rate is 0, and we have the death rate is 0. We know these things were dying off. So the death rate was definitely not 0. So we can get rid of birth rate. Or we can get rid of, not birth rate is 0. We can get rid of the death rate was 0 because we know these things were dying off. So get rid of those. Okay. Number 3. Study 1 differed from study 2 in which of the following ways? Well, we already know like one was 5% and one was 15%. I don't remember which one was which, but we know that that was different. So let's look at A and B and C and D and see if that helps us. A says female fruit flies were tested in study 1, whereas male was tested in study 2. Have no idea. Could be true, could be false. So we'll leave it in the mix. B, male fruit flies were tested in study 1, whereas females were tested in study 2. Again, could be true, could be false. C, the SY medium tested in study 1 contained a lower percent of sugar than the SY. Here, now we're talking about that 5 and 15%. Okay, so who was who? Let's see. Figure 1 was higher than figure 2. So figure 2 was lower than, anyway, figure 1 was 15, figure 2 was 5. Let's go see who fits that regiment. C says study 1 contained a lower percent. Nope, study 1 was 15. So that's not true. Study 1 contained a higher percent than study 2. Yes, that's true. So D is true. I don't care about A and B. If I find an answer that's right, take it. Okay. 4. Suppose that an additional trial in study 3 had been performed using a 12% SY medium. The average lifespan of the strain X fruit flies in this trial would most likely have been what? Okay, 12%. Well, 12% is not in my table, so I'm going to have to put it in my table. So X, that's down here, and 12%, that's going to be in between 10 and 15. So right where that red line is. Okay. And they want to know what the average lifespan would have been. Well, 12 is between 10 and 15. So my average lifespan is going to be between 55 and 58. Makes sense? I mean, just apply a little common sense, right? Okay. So go to your answers. Between 55 and 58 looks like G. And that's one of your prediction questions, but it's just predicting your between, not over or under. Okay, number 5. The researchers had predicted that decreasing a fruit fly's ability to detect odors. Decreasing a fruit fly's ability to detect odors. Which one can't smell? X, yeah, okay, so we know we're probably dealing with strain X. Are the results of study 3 consistent with this prediction? Oops, I didn't read the rest of the sentence. That was bad. The researchers had predicted that decreasing a fruit fly's ability to detect odors would increase its lifespan. Are the results of study 3 consistent with this prediction? Okay, so they're saying, this prediction is saying that if you take away their sniffers, they should live longer. Did that happen? Yeah, in fact, we marked it. X is living longer. So yes, X is living longer, so we know we can get rid of the nose. So C says yes, for each SY medium tested, the average lifespan of X was longer than the average lifespan of N. Yes, that's what we wrote. X lives longer. So it's C. D just says the opposite, N lived longer than X. So D is just backwards. All right, number 6. Suppose researchers wanted to determine whether a defect in the ability to detect odors, so again, defect ability to detect odors, that would be strain X, would change the lifespan of fruit flies fed a 15% SY medium. Ooh, 15%. Which one was that? Was that experiment 1 or experiment 2? That was 1. So we have X. We know we're dealing with X, and we're dealing with experiment 1. Okay. Whether the ability to detect odors, X, would change the lifespan of fruit flies fed 15% SY medium, experiment 1. When live yeast is added to the diet or when additional odors from live yeast are added to the diet, which of the following experiments should be performed? Oh, well, we already figured that out. Experiment 1 with X. So experiment 1 with X, that would be F. Okay. So without even reading the whole question, we already had the answer because we're paying attention to what they're talking about. Number 7, the results for which 2 tubes should be compared to determine how a reduced calorie diet affects lifespan in the absence of live yeast and additional odors of live yeast. So absence of live yeast and additional odors from live yeast. That was not anywhere on our charts or graphs, so that must be a passage question. Okay, and that's the end. This one only has 7 questions. So we're going to look for those 2 things in the passage. So we're looking for, if we look at the answers for number 2, it says because the initial population contained only males or because the initial population contained only virgin females. So we're looking to see whether they used males or females. And then for number 7, we need to figure out which tubes had nothing else added to them because we're looking for the absence of live yeast and additional odors. Okay, so let's go to the passage and let's figure out whether they used males or females, and then we want tubes that had nothing else added to them. Okay, so right away in study 1, again, I'm just scanning. I'm looking for the words male or female. Aha, right here. "200 virgin females." So they're using females. So that's going to let me answer number 2 right away. So number 2, they're using only virgin females. That's got to be G. Done with that. Then number 7, I need tubes that had nothing else added to them. Okay, so keep reading after the virgin female part. Strain N fruit flies substance, strain N fruit flies less than 24 hours old were added to each tube. No additional substance was added to tube 1. Okay, right there. So I know I need tube 1. And let's see what they did in experiment 2. I'm going to look for that same sentence in experiment 2. Blah, 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 blah. Aha. No additional substance was added to tube 4. So I need tube 1 and tube 4. Tube 1 and tube 4. Okay. That's the end of your first science passage. Any questions? Not too bad, right? Okay. Now let's deal with the beast. This is the arguing scientist people. All right, so here's the deal with this. You want to actually take notes on this as you go. So this one, I'm going to put the notes on the board, but then I'll do the questions in there. So let's see, I can move this whole thing over. Perfect. Okay. All right. So when you're dealing with arguing scientists, guys, you actually have to read the passage. Like, there's no way around it. There's no point in looking at the questions first. Okay? So let's just go ahead and read through, and we'll take notes as we go. But we're only going to read one hypothesis at a time. So first, you always want to read the opening passage, the opening paragraph. It's going to tell you what they're arguing about. So then you know what you have to take notes on. So in the fall, monarch butterflies in eastern North America migrate to Mexico, where they overwinter in high altitude forests of whatever this fir tree is. The butterflies store body lipids to use as a source of energy at a later time. Consider the following three hypotheses pertaining to, this is going to tell me what they're arguing over. When the butterflies store lipids and when the energy from the stored lipids is used. Okay. So I need to keep track of when they're storing and when they're using lipids. So when are they storing lipids? When are they using lipids? That's what they're arguing over. And this is with respect to migration and overwintering. Okay, got it. Hypothesis number one. All right. Monarch butterflies require energy from stored lipids for migration. Okay. So when are they using them? They're using them for migration. I'm going to abbreviate here, migration. And during the overwintering period, 2 times. So migration and overwinter. The butterflies first store lipids before they begin their migration. Okay, so they're storing lipids before migration. Before they begin their migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. Okay, so lipid mass decreases during migration. Just going to keep track of that. When the butterflies reach the overwintering sites, ending their migration, they must store lipids again before beginning the overwintering period. So they're going to store before migration and before overwintering. Okay. So they have 2 periods of using lipids and 2 periods of storing. All right. That was hypothesis number 1. Let's go to the questions. See what we can answer. Move this down a little bit. Okay, number 8. Which hypothesis, if any, asserts that monarch butterflies store lipids during 2 distinct periods? Is that true for hypothesis 1? Do we have 2 periods of storing? Yeah, that's true for this guy. Okay, so hypothesis 1. We've already answered question 8 without reading the rest of it. Number 9. Which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor during the overwintering period? Is that true for hypothesis number 1? No, that's not true for hypothesis number 1. We know that they're using them during migration. So we're going to cross out hypothesis number 1, but I can't do anything else with that. Number 10 says, based on hypothesis number 3. Obviously, I can't answer that. So on to number 11. Assume that changes in the body mass of a monarch butterfly are caused only by changes in the mass of the butterfly's stored lipids. The statement, the percent of a monarch butterfly's stored, let's try it again. The percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end, is supported by which hypothesis? Well, lipid mass decreases during migration. So, according to this statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end. Yeah, that's true for hypothesis number 1. If it's decreasing during migration. So hypothesis number 1, yes, it's true for him. So what can I get rid of? I know hypothesis number 1 has to be included, so I can get rid of hypothesis 2 only. Okay, because I know 1 has to be included. 12. To store lipids, monarch butterflies convert sugar from nectar they have consumed into lipids. A supporter of which hypothesis, if any, would be likely to claim that to ensure butterflies can store lipids for overwintering period, nectars must be present at overwintering flight sites. Okay, so this one is talking about they have to store lipids for overwintering period. Okay, so that's true in our case. We have to have lipids for overwintering so that they can use them. And before they go into that overwintering period, they have to store them. Okay, it's kind of like a bear. He's got to eat a whole bunch before he goes hibernating. So he has energy during hibernation. So same idea here. They're going to have nectar. They're going to have to have something to eat on at that overwintering site before they go into the overwintering period, just like the bears need food before they go into hibernation. Make sense? All right. So yes, hypothesis number 1, that would be true because we need to store lipids at the overwintering site before we go into overwintering, where we need to use them. So hypothesis 1, that's true, and I can only pick one, so I'm going to have to take hypothesis 1. Okay. 13. Which of the following statements about lipids in monarch butterflies is consistent with all 3 hypotheses? A. The butterfly's lipid masses do not change during the overwintering period. Is that true for hypothesis number 1? Yeah, I see a bunch of you shaking your heads, right? That one's going to be false for hypothesis number 1, so we can rule it out because we're looking for the one that's consistent with all 3. B, the butterfly's lipid masses change during migration. Well, yeah, we know that happens. We wrote it up there. Lipid masses decrease during migration. So that's true. C, the butterflies use energy from stored lipids during the overwintering period. Okay, so this is use during overwintering. Where do we have it there? Use overwintering. That's true. Keep it. D, the butterflies use energy from stored lipids for migration. Use migration. D is a keeper. 14. Number 14 is one of the 3 questions in 15 years that I have encountered where you need outside knowledge to actually answer this question. And of course it's biology. When the monarch butterflies use their stored lipids, the lipids must be broken down to produce energy-rich molecules that can be readily used by cells. Which of the following molecules is produced as a result of the breakdown of lipids? Okay, all right, biology people. I am not a biology person. Who knows what you get when you break down lipids? It is ATP, yes. I had to look it up. I had no idea. I'm like, you give me a chemistry or a physics question, I can probably do it. You give me a biology question, I got no clue. All right. So we've done everything we could do based on hypothesis number 1. Now we got to go back and do all of this again for hypothesis 2. You see why this could take you so long? I mean, this one only has 3. Can you imagine if you had 5? But if you try to do it all at once, you will mix up who said what. Guaranteed. All right. They're cheering us on. We can do science. Okay, hypothesis number 2. Monarch butterflies require energy from stored lipids for migration. All right, so that means they're using lipids for migration. But not during the overwintering period. The butterflies store lipids before they begin their migration. So store before migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. Okay, so lipid mass is going down during migration. Because energy from stored lipids is not required during overwintering period, the butterflies do not store lipids while at the overwintering sites. Okay, so that's it for hypothesis 2. All right, 8's done, so we are on 9. Which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor for the overwintering period? Does that apply to hypothesis 2? No, it doesn't work. Still can't do 10. That's based on hypothesis 3. 11. All right. Assume changes in body mass of a monarch butterfly are caused only by changes in the mass of the butterfly's stored lipids. The statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end. is supported by which of the following? Does hypothesis number 2 support that statement? Yeah, their lipid mass is decreasing the whole time, at least during migration. So hypothesis 2, that is true. So we can get rid of 1 only. We know 2 has to be included. All right, on to number 13. Which of the following statements about lipids in monarch butterflies is consistent with all 3 hypotheses? B, C, or D? B. The butterfly's lipid masses change during migration. Yeah, it's decreasing. C. The butterflies use energy from stored lipids during the overwintering period. Is that true for 2? No. Get rid of that. The butterflies use energy from stored lipids for migration. Yeah, we have used for migration. So that's that. All right, last one. Usually by the time we get done with this passage, people are like, I hate butterflies. Okay. Hypothesis 3. Monarch butterflies require energy from stored lipids during the overwintering period, but not for migration. Okay, so this dude is like backwards of everybody else. They're going to use during overwintering, but not during migration. The butterflies do not store lipids before they begin their migration. Instead, lipids are stored during migration. Okay. Therefore, lipid mass continuously increases from the beginning of migration to the end of migration. Again, backwards from everybody. The butterflies arrive at the overwintering sites with enough lipids to provide themselves with energy during the overwintering period, so they do not store lipids at the overwintering site. There we go. All right, we should be able to finish this guy off. Number 9. Which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor during the overwintering period? Is that true for 3? No, he needs them for overwintering, so it's got to be D, none of the above. We can finally do number 10. Up there. Based on hypothesis 3, which of the following figures best depicts the change in the lipid mass of a monarch butterfly from the beginning to the end of migration? Again, this is based on only hypothesis number 3. Well, what's going on during migration for hypothesis number 3? Lipid mass is increasing and increasing only. So which graph is increasing and increasing only? J, gotta be J. I keep wanting to take the marker and mark the answer on my computer screen, which would be very unfortunate. Okay. This is called lack of sleep. Number 11. Assume that changes in the body mass of a monarch butterfly are caused only by changes in the mass of the butterfly's stored lipids. The statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning than at the end. Is that supported by hypothesis 3? What's happening with hypothesis 3? His lipid mass is going up during migration, right? Okay, so does that statement work, that it would be greater at the beginning than at the end? No, it should be the other way around. It should be greater at the end than at the beginning. So hypothesis 3 is not supporting that, so let's get rid of D. It's got to be C. Last one, number 13. It is on the screen. Which of the following statements about lipids in monarch butterflies is consistent with all 3? We have the butterfly's lipid masses change during migration, or they use energy from stored lipids for migration. Well, we know that they only use during overwinter for hypothesis 3, so it can't be D, it's got to be B. There is a change, it's just an increase instead of a decrease. So B is true. And we have successfully completed the arguing scientist passage. Pain in the batoot. Sir?
How long on the actual test should you dedicate to that one?
That's why you put it last, because if you run out of time on that. Yeah. Your goal is to be able to do these, hopefully. So you have 40 minutes for the entire test. I would try not to spend any more than 7 minutes on this. it's going to take you a lot of practice to get it down to that. That's why I say if you're going to run out of time on this, especially if you have like 5 opinions. Okay. Questions, concerns? Okay. It takes a lot of practice, guys, and you need to practice because you got to get your time up. You got to be able to go pretty quick. Not just with this, but also with the other passages. Any questions in general about science? About grammar, about life? Okay, we're done early. We're good. That's it. That's all I wanted to get through. Let me give you guys answers to the rest of those. Where are they? Here they are. So homework-wise, it's just, the homework assignment is just out of your ACT book. But you can also use the rest of this practice test for extra practice if you want. What I'm giving you now are the answers to the rest of that packet, the rest of that test that I handed you. So these are the answers to the rest of what you have.